So, Atul, could you start us off here? I think this is sort of GCSE level question. Could you start us off with just the equation, the general balanced equation for this reaction?
Sure. So this is a potassium carbonate aqueous with nitric acid. So I'm going to use my pen tool. I like purple. I'll just double check we're on purple. So I click on this pen tool down there, which may or may not show on your live stream, but there's a pen tool. And or shortcut 2 on the keyboard. So purple there. Potassium carbonate. So the carbonate is CO3. Potassium is K. Potassium is in sodium group 1, so it's K2CO3 plus HNO3, I believe. So I'm writing this time. Stage symbols AQ, AQ. I'm live, so a little bit of stage fright, messy writing, so, but you know, no big deal. I'll just correct that with the edit tool. Gonna put a forward arrow using the arrow tool.
Mm-hmm.
All right, so potassium nitrate, same. Potassium nitrate, no, not K2. Yeah. Potassium nitrate, so I can edit this in, plus carbon dioxide plus water, liquid, gas, aqueous.
Excellent. How did you know it was KNO3 and not K2NO3?
I know that the nitrate ion has a net negative charge, and I know that the potassium ion has a net, well, a positive charge, one positive, and therefore they must combine in a ratio of 1 ion of potassium with 1 ion of nitrate.
Yeah, because ionic compounds overall are neutral, so that the plus and the minus there cancels out, and the K2CO3, we needed 2 potassium ions to cancel out the 2 minus charge on the carbonate ion.
Yeah, so keeping it neutral, yeah, the plus and minus. So I'll just take that out.
Okay. So now to turn this into ionic equation, we just write out the aqueous ions that are here. So we would have 2 aqueous potassium ions and an aqueous carbonate ion. An aqueous hydrogen ion, aqueous nitrate ion, making this a bit big. So aqueous potassium ion, aqueous nitrate ion. And then we've got our carbon dioxide gas. And water liquid. Yes, we needed to balance the first equation. So how would we balance the first equation?
Of course, I never balanced it. Right, I love my colors, so I'm just gonna switch to another color. So I'm gonna go black. So 2 potassiums there, 1 there, suddenly out of whack, not balanced. I'm going to stick a 2 there. So that changes the nitrogen number. So I've got to stick a 2 there. Nitrates all good, potassium all good. 1 carbon, 3 oxygen. 2 hydrogens extra, are they? Or hydrogens are good as well? Hydrogen's looking good as well. Or is it 6 oxygens? 7, 8, 9.
Yeah, that's fine.
Yeah.
Yeah, that's fine. So that affects the number of ions we've got down here. So this would be 2H plus, 2NO3 minus, 2K plus, and 2NO3 minus. And now can you spot what we need to do with this ionic equation?
To preserve the equality, as I say in maths, I can remove the 2NO3 minus there and 2NO3 minus there, both on the left and right.
And anything else we could remove?
And the 2K plus, yeah, of course, that and that.
Yeah, and they're known as spectator ions. Essentially, they've just watched this reaction. They haven't changed.
Brilliant.
So they've not really taken part in the reaction. And so we can ignore them in our overall ionic equation.
Nice. That's not something we hear at
So
GCSE.
if we remove that, remove that, remove that, and remove that, is our overall ionic equation. Essentially, you can see there an acid and a carbonate gives carbon dioxide and water.